Welcome to Amber Skies. Hello there, I'm Blades. And today we are doing something. We're exploring OpenGL Vertex Array Object. VAO. What do I know about VAO? The letters, probably. That's about it. Vertex Array Object. What's one of those? Let's take a look. See what we can do. Here we go. Now, a vertex array object is roughly goes like this. You have all of these buffers, like 14, 15, well, up to 32 of them, and they are held on this page. Say, one line is, there we go, well, 31 it would be, isn't it? No, it's 1, isn't it? So 32. So there you go, 32 lines, there's a buffer on each line, and the whole page then is an array of buffers, or a list of buffers, and that's what the vertex array object is. By definition, or as of 3.3 or 3.0, you must have one. So we do have one already. It's just that we have the default one, the one it's giving us. So what we're going to do is our own. How's about that? Why not? Let's take control of this. Let's cook on gas. Let's do something real. Shader program, buffers. Okay. Let's see if we've got one, because I don't know what I'm doing. Q open GLV. Ah, there we go, vertex array object. That's the one we're after. Copy that. See what I've got up on help at the moment. Shader programs, okay. Search. Okay, vertex array object, here we go. So what is it? Described as an OpenGL container, like a sheet of paper. The encapsulates the state needed to specify per vertex attribute data to the OpenGL pipeline. In other words, any changes that we make to our buffers, it records. And that means changes like we're going to make. Let's have, for instance, colour. Oops, put that comma in the right place. Yeah, we'll have colour. What else do I want? I'll have a matrix of MVP. That doesn't mean anything to anybody right now. That's good news. I also want one of these, don't I? So let's have one of them. That looks interesting. Let's pop it just there. And let's call it star m underscore object 1 VAO. I think that's the best way of describing it, because we're going to have one VAO for each object that we could put on the screen. I think that doesn't come as a surprise to anybody. We have to get it from somewhere. We have to start controlling this object somehow, and that's next issue. That's preempting the next video, I think, really. Do we need anything else? We've got a VAO, we'll add colour, and we'll add MVP. Yeah, okay. Alright, so let's do the GLSL bit first. We have to obviously do something here. So on our vertex shader, we're going to have a layout, location. Let's keep them in order, I suppose. So 1 in vec4, and this can be colour, spelt the American way. Do the stars and stripes, you Americans, do it now. I'm also going to introduce something called a uniform. in this episode, and this is important, very important. It's going to be a mat4 in this case, and it's going to be it's a uniform U underscore MVP. There we go. Now what we're going to do with that is we shall make a vertex color, or vertex shader color, and we're just going to make it equal to color. We're not going to do anything with it at this point. Okay, and here we'll just tell it that out vec4 vertex shader color. There we go. That's the whole thing then. We've got our color passing through, and we've got, oh, we haven't used UMVP yet, have we? So we can have U underscore MVP times position. And I will go into MVP a bit later, but we already have P. P for perspective, we already have that. V is for view, that comes from your camera. M is for model, that comes from the model rotation, location, and that kind of stuff. So that goes in that one. It should really say PVM, but anyway, it's MVP. Not most valuable player, as you may expect. Save. And your fragment can now have this colour coming in. Now we're not going to do anything with the colour, but we've got it coming in, so we better recognise that. So I've got an in vec4 from the vertex shader and its colour. Semicolon. And instead of putting that, I'm just going to put v underscore colour. There we go. Simple as. We need to address, before we address the colour, we need to address the uniform. That's going to be the first thing. So we'll save those out. Looks good. Save those out. And we're back to this header file. Okay. Let's have a look. Let's explore source. Test2. We've changed them to. So we'll copy them. And we'll go back to explore. In here we've got copies of them. We'll just paste them in here. Paste 2 items. Apply to all. Overwrite. Thank you. Fantastic. Now, we've copied them because that's where our program will be running and it will need access to the shaders, so we copy them over. We're only storing them in here for ease of viewing, I suppose. Where should we start? We've done this bit now, haven't we? Let me just split the window a second. There we go. Because I've altered our header file somewhat. Let's go to our source. What have we altered? We've added that. Make a copy of it, please. And we popped it in just after program, did we? Yeah. Okay, so B open, and it's just going to be Q open GL V vertex array object. There we go, that one will do. No, I don't really want that one. I just want the words, I don't want anything else. There we go. So that's a Q OpenGL. It's not working. Help. Did I do this right? OpenGL Vertex. Oh, easiest way to do it is copy that. Pop that in there. Go outside of the brackets. And put a comma. Is that okay with you? No, it's not. Why not? What is it actually saying, the issue? does not refer to... Oh, that's right, yes, it's a new one, isn't it? So, new, yes, good idea. Let's new it all up, which means that we now need to destroy it. Position and index, position and index. Index is last, so go, oh, we'll stick it here. We'll put it here. But we do need to destroy it. Position buffer. Oops. No. Object. And all I want to do is arrow destroy. Thank you. That's lovely. Thank you very much. We need a comma. And I've got color underscore color, please. Start that at 0. And underscore MVP. Model view perspective. We shall start at 0 as well. There we go. Because we can. Here we go. I can do copy that. Pop it there a second, will do. And also, what else have I got here? I'm not overly using color. Yeah, and underscore MVP equals something there. That's underscore color. That's going to be color. And that is going to be underscore program. And that's going to be uniform. Uniform location. Yeah, constant chart name. Yeah, that's right. I've done it again. Let's invert U underscore MVP. There we go. Lovely, lovely. Got to be exact. They have to be exact. And I'm going to make sure I've done it exact. Vertex it was, wasn't it? UMVP, yep. Color, position, must be exact. Not in the same order, but you know, with these V's and things that underscores that I put in. Right, we can get rid of this now, can't we? We know what we're doing, don't we? Okay. Let's make colours. Let's do it after. Well, it comes with this one, doesn't it? It's still a vertex thingy, isn't it? Oh, we need another buffer. Can put it in here. Open GL buffer, and it's just going to be star underscore color buffer. There we go. Nice and easy. Copy, save, get rid of, and we're doing this one just after. So it's that one there. And all we're going to do is open the inverted commas and just copy whatever this line above says. That one there, please. Copy. And paste. Ending in a semicolon. Oh, comma. And we're going to need to delete that. Goes in between position and index. So in here, please. Underscore color buffer, and it's destroy, is it? Yeah. There we go. Always clean your memory up even before you use it. We've got these going through nicely. Okay, yeah. We've got those going nicely. We've got vertex buffer object. Okay. Yeah. Let's have GL float. We decided to have these as. And let's call this colors two thingamajiggy square brackets, because it's an array. It's funny, everything's becoming arrays all of a sudden. What I'm going to do is, I'll do a colour for each vertex. How about that? The first one make red, next one green, RGB, and then white, I suppose, I don't know. So it's 1.0f, comma 00f, comma 00f, comma, and the last one is 1.0f. So we can't see through it, alpha channel. This is 0.0f, comma 1.0f, comma 0.0f, comma 1.0f, semicolon. No, it's a comma. Dar. And it's 0.0f, comma 0.0f, comma 1.0f, comma 1.0f, comma backspace. Thank you. And the last one will just have a white, full RGB. And you can't see through it. Okay, that's lovely. So we've got 4, so it agrees with our vertices. We've got one colour for each vertice. Lovely. Our index will pick up on that, I hope. What won't pick up on that is this. So m_color buffer is create, please. There we go. Color buffer bind, please. And the last one is color buffer and allocate. And it's going to be colors. And it's going to be size of colors. And that's it. There we go. Lovely. So I've recorded all our data. If we aren't using a VAO, then we now have to come down here and add it. Will this work without the VAO? Probably, yeah. M_color buffer bind. Oh, we didn't close it down, did we? Whoops. It came after, so it goes in there. So M_color buffer release, please. And that's that done. Yay! Color buffer bind, and it goes there. Yeah. M_color buffer, and that will be. Ooh. And that will be release. Fantastic. There we go. And we'll need a couple of these, won't we? So we'll need to repeat these 2 lines. Because now we have colour. Are you seeing what's happening though? It's getting a bit much, this. Yeah, that's right. M_color, I think it is anyway. I'll check in a minute. Yeah, it looks like it is. Lovely. Will that work? Ah, wait a minute. I've got this MVP in, haven't I? With the uniform. Okay, how do I get around that? I'll need an extra 2 lines, won't I? Good God. M_MVP and that will be set. It's an int. Oops. Okay. We need a matrix. We haven't got one. We need a Q matrix. Oh, that's bad. We haven't got one. Test 2, please. Can we have matrices? Hash include, and we will call it Q matrix 4x4. Yeah, that's good. I'll pop it here, and it's Q matrix 4x4. What should we call it? M underscore MVP. Can't. Because that's its position. Full matrix. I don't know. What happened there? There we go. Full matrix. We'll just call it the full matrix for now. You'll understand why in the next video. I'm going to take that, make a copy of it. I can't initialize it because it's a matrix. It's already initialized as soon as it's made. But what I can do here is take the full matrix and then dot set to identity. There we go, that'll all be explained to you. And then we need that uniform, don't we? So it's going to be program set uniform location MVP. Okay. Let's see if we can do that one. So that's going to be m underscore program. What? What's happened to that? I don't know. I just pushed some. Wait a minute. Insert. Right. I pushed insert, didn't I? Why have I got a line there now? Weird. Okay. Just put you there for a minute. M program. So it's going to be set uniform value. Location value. Okay, so the location is m underscore MVP, and the value is going to be m underscore full matrix. Set it to identity so it'll work. Yeah, we'll alter that in a minute. Okay, so I've covered all the variables. Now we've got our color and our uniform value, full matrix. Look how it's done differently. Yeah. You see, our uniform value isn't a bunch of data like this or this. It's set to a specific value for each of these draw calls, whereas these are being dragged through or streamed through as a set of vertices. Yeah. So they're varying inside our vertex shader here. They vary. And this is uniform. So for the whole lot of the positions and colours that we send through here, that's going to be one value. And it can only be one value because we only set it once. And that's here. So that's the only time we set it to a value. Right, got that out of the way with very carefully. We've got colours. Alright, let's see what mess I've made. I must have got something wrong in that lot. Test 2, test 1, test 2, it's not working, test 1, there we go. Good, it's not working, that's what I like to see. It's better that it doesn't work at this point than it does, because what I've done, I've just thrown it an absolute load of rubbish and hoped that it would work, and of course it doesn't, because that really doesn't give it, you know, much of a chance of working, really. If I were to take this out of here, cut, and put that with the first bit, that's then all of our colour stuff. Is it position? No, sorry, this is all of our position stuff. And then I put all of our colour stuff together. That's those two lines there. Cut. There we go, so it makes more sense. Like that. So now that makes more sense. We've got create and enable the attributes for the position, vertices, well, numbers, and create and set the attributes for the colours. Now to make this work, we are going to need a VAO. So what I'm going to do is I'm going to nick that, copy, paste, vertex array object, that comes in here. Let me just make sure I've got everything going on alright up here with these positions and stuff. Yeah, I think they're in the right place. Remember, I only think they're in the right place, doesn't mean a damn thing. Do I need that as a colon anything? Don't know at this point. Bind the VAO, set the vertex data, unbind, release. Okay, we'll do that. Okay, we'll do that next then. So, our object, which was m_object, which is the right thing, we are now going to create. We are then going to bind it. Bind there. That's that done. We now need to release it. And it has to be the first released. So we can release it here. This is looking already messy. And we can bind it again here. So we bind it. There we go. I think we can leave that there for now. And we can unbind it or release it again, so it doesn't interfere with anything else that we're doing. We have to be aware that it could interfere with other things, so there we go. Does it work now? I like exploring like this. There it goes. That's that. That's that. It now works. But hold on a minute. We've just put that in. And if I look at that help, it just says bind the VAO, call the draw, and unbind. Alright, let's try that. So I still need that bit. Let's take out position buffer, color buffer, index buffer. I still need that because we still have to call that once per draw call no matter what we do. And that can only be called whilst we're bound to the program. Okay, so let's get rid of that, that, and that. I'm going to clean all just to make sure it compiles fully. Build all. Takes a bit longer, that's all. There it all goes. Lovely jubblies. Takes 10 seconds to do that. Oh, but it's still working. So we didn't need all of those lines. And it's very pretty, of course. But it's still og blonde. It's not square, right? Let's get that perspective working, I think. Now this bit is very interesting. Let's just get rid of these lines we don't need anymore. This bit is so interesting that it creates a headache if I try and do it quickly. So I'm not going to try and do this quickly. We've got ourselves to the VAO. Let's forget about that for a minute. Let's look at this matrix, this perspective, because we could theoretically put in here Q matrix 4x4, and let's have perspective. Yeah, that'll do. And that will alter that automatically by clicking on the little light bulb. So that's done. But that alters something else. That alters going backwards exploration. That's now wrong. Look, draw test 2. Oh well, luckily we've got our perspective here, so let's just nick that. It's a pointer, and I haven't asked for a pointer, I've just wanted the value. So paste that in there. It is a pointer, isn't it? Yeah, it's got a star on it, so we have to dereference it. So we get the dereference it to the value, just do that, and it'll do it for me. That's nice. Now if we put the perspective in, we're still not using it. I'll show you why. Because I'm actually setting it. That's why. So, what are we throwing in here? Full matrix. We're still setting it to identity, but just here, m underscore full matrix underscore matrix will equal perspective, and then semicolon, and then I'm just going to put a note afterwards, view, and it's MVP, isn't it, model. And those three things are all matrices. 4x4 matrix. If you don't know what a matrix is, it's a little black box of numbers that makes everything work. That's the best way of keeping it. Keep it in your mind as a little black box of magic that you times it by things and it just works as long as you times them in the right order. Why don't we call it PVM? It's because it's to do with the mathematics of matrices. Don't worry about it. It's model view perspective. So how are we looking now? Oh, still setting it to identity, so it should just be the same, and it is. Okay, so let's stop doing that, shall we? Because all that's doing is making, just stopping that value coming through to the setting line. So we'll take that out now. We've got our perspective, it's coming through. We know that it needs to come through separately and that we need another 2 values yet to multiply out to get the full matrix. I'm preempting the next video, don't you worry. And what do we get? Can you guess before I click on the button what we get? Do we get a square? Do we get an oblong? Do we get a triangle? No, we get nothing. Why? Why? Why do you do this to me? We get nothing. Nothing at all. It's simple. Were you not reading when I was doing that? What perspective equals? 55. Let's have a look. Let's have a look closer. There it is. Float vertical angle, float aspect ratio, float near plane, and float far plane. Well, we've got a near plane of 10 centimeters or 0.1. Remember, I said 1 was going to be a meter from now on. 55 degrees up and down. The aspect ratio is whatever is worked out in the resizing of the window. 0.1 is the nearest thing, so anything that's under 10 centimeters in front of us, we can't see. Anything that's further away than 100 meters from us, we can't see. So where are we drawing this thing? 0, wasn't it? We just ignored it. So look at our data. Verts, x, y, z, 0. Well, we can't see anything at 0. The closest it can be is 0.1. So let's stick it all out there 1 meter away. Remember, this is a 1 meter by 1 meter cube because it's going plus 0.5 to minus 0.5. So that's a full meter. So it's a 1 meter by 1 meter square that we've actually drawn. Let's test that out. Can you guess what we're going to get this time? Are we going to get an oblong, triangle, square? We get nothing. And that was our vertices that we just changed. So we know we're looking at it, but we're still not getting anything. What have we changed that's really upset it? Well, obviously, this. Just gonna do a full clean all again, just in case I'm missing something. I can do it down here, can't I? Full build, please. Just want to make sure it's compiling the shaders and everything's out of memory from before. La, 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 la. Test 2's not working. 4x4 matrix comes into perspective. 4x, we can actually just put perspective there, can't we? What is M full matrix? It's just a cube 4x4. What happens if I do put perspective in there? Just out of interest. Should be the same thing, you would think. Yeah. Not as much. There we go. Program bind. Shove in a matrix and it disappears. Which means we have something wrong here, I would suspect. MVP equals mprogram uniform location MVP. Yeah, okay. And here we are setting the uniform location to a full matrix. It's saying GL float there. Does it actually accept what I'm doing? That's the difference. checking through memory on the other bits and pieces. So it'll just be above, won't it? Will it? No, it'll be below. Let's page down. This is a biggie. And that's an OpenGL Vertex array object. Okay. That's not what I wanted. Shader program. Yeah, set attribute value. Here we go. Set uniform. So yeah, it just accepts it. This is an overloaded function, so I'll accept it. Okay, it's fine. Let's see if I've done anything wrong here. So uniform, vec4 matrix, and then it's matrix times position. Yeah. Int. Yeah. I didn't check to see whether no, VAO's okay. We can check that. Doesn't seem to want to work. So it looks as though we're going to do this perspective in the next one with the view in the model. Shame. I would have liked to have got that working. So full matrix set to identity. That, and that will make it work. Or should do. There you go. But it's nice and colourful. We've added colour. That was the main thing. And if you have a look at our draw call, it's got a bit messy because of this, which obviously we're working on. But you can also tell that we're only actually binding two things now. We're binding the shader and the VAO. And extra information, as soon as I get this worked out, will be going in through uniform values properly so that we can turn this around, make it square, get the perspective right, would help. I think we need to do that somehow. And yeah, I'm quite chuffed with that. I'm quite pleased with what we've got. Let's have that. We've explored. We've come here, we've kicked butt, and we've got a shiny new thing. Take care, people, and keep exploring, will ya? Oh, and have fun.